Ladies and gentlemen, imagine spending tens of thousands on a car that could cost you even more if you make just a few mistakes. Today I'm going to reveal the 15 most expensive errors Tesla owners unknowingly make every single day. Mistakes that silently destroy performance, shorten battery life, and rack up repair bills you never saw coming. If you own a Tesla or dream of driving one, you cannot afford to miss this. Stay with me because what you're about to learn could save you thousands and keep your Tesla running like new for years. Every detail of a Tesla vehicle is engineered with precision, intelligence, and long-term performance in mind. Yet even the most advanced technology can be compromised by habits that seem small, but carry significant consequences over time. Ownership is not just about driving. It's about understanding the system you're interacting with. And one of the most common and costly mistakes is frequently charging to 100% when it's not necessary. The battery system is designed for optimal longevity, when kept within a balanced range, typically between 20% and 80% for daily use. Constantly pushing beyond that limit accelerates chemical wear, gradually reducing range and efficiency. Fast charging, while convenient, should also be used with awareness. Relying on it excessively introduces additional heat stress to the battery pack, which can compound degradation over time. And temperature management is another overlooked factor. Parking under extreme heat without cabin overheat protection or preconditioning can affect not just passenger comfort, but also internal electronics and battery health. Similarly, ignoring preconditioning in cold climates leads to reduced regenerative braking and inefficient energy use. These systems exist to maintain peak performance. Using them correctly is essential, and driving behavior directly impacts long-term durability. Instant torque is a defining feature, but aggressive acceleration and hard braking place unnecessary strain on tire, suspension, and drivetrain components. Smooth, controlled driving not only extends hardware life, but also maximizes range efficiency. Tires in particular wear faster under high torque conditions, and neglecting rotation or pressure checks leads to uneven degradation and reduced safety. And software is at the core of the Tesla experience, and ignoring updates is a critical error. Updates are not cosmetic. They refine battery management, improve safety systems, and enhance driving dynamics. Delaying them means operating on outdated logic, while the system is continuously evolving to perform better. Equally important is understanding the capabilities and limits of driver assistance features. Misusing them or overestimating autonomy can result in avoidable damage or unsafe situations. And another costly oversight is improper charging habits at home. Using low-quality or incompatible outlets, failing to install proper electrical infrastructure, or neglecting grounding requirements can lead to charging inefficiencies or even hardware damage. The vehicle is designed to work seamlessly with stable, regulated power sources. Cutting corners here introduces risk. And interior care also plays a role in preserving value. Using harsh chemicals on vegan leather or touchscreen surfaces can degrade materials prematurely. The cabin is built with sustainability and durability in mind, but it requires appropriate maintenance products to retain its condition. Similarly, ignoring small issues like unusual noises, alignment changes, or warning alerts often allows minor problems to escalate into major repairs. And storage habits matter more than many realize. Leaving the vehicle at extremely low or high charge levels for extended periods can negatively impact battery calibration and health. If the vehicle is not in use, maintaining a moderate state of charge ensures system stability. Additionally, failing to enable features like energy-saving modes or Sentry mode selectively can lead to unnecessary battery drain. And overloading the vehicle beyond recommended capacity or improperly distributing weight can stress structural components and reduce efficiency. The design prioritizes balance and aerodynamics. Compromising that balance affects both performance and safety. Roof racks, external modifications, or non-approved accessories can also disrupt airflow, increasing drag and reducing range. And neglecting brake maintenance is another subtle issue. Regenerative braking reduces wear on physical brakes, but this can lead to corrosion if they are rarely used. Periodic use of traditional braking ensures they remain functional and responsive. It's a small adjustment that prevents costly replacements. And finally, misunderstanding energy consumption patterns leads to frustration and inefficiency. High speed, strong winds, steep inclines, and heavy loads all influence range. Expecting static performance regardless of conditions overlooks the dynamic nature of electric driving. Learning how to read energy graphs and anticipate consumption allows for smarter, more confident operation. And Tesla ownership is not complicated, but it is intentional. Every system is designed to reward awareness and precision. Small habits, when aligned with the engineering philosophy, preserve performance, extend lifespan, and maintain the seamless experience the vehicle was built to deliver. And understanding charging infrastructure compatibility extends beyond basic functionality. Not all charging equipment delivers consistent output, and fluctuations in voltage or improper installations can introduce inefficiencies that slowly impact system reliability. Ensuring that certified equipment is used and regularly inspected aligns with the vehicle's design expectations. Even cable handling matters. Frequent bending, improper storage, or exposure to harsh conditions can reduce lifespan and charging performance over time. And attention to aerodynamics is another area often underestimated. The vehicle's shape is carefully optimized to minimize drag, and even small external additions, such as poorly fitted accessories or leaving windows slightly open at high speeds, can disrupt airflow. This increases energy consumption in ways that are not always immediately noticeable, but accumulate over extended use. Maintaining the integrity of the exterior design directly contributes to efficiency, and wheel and tire selection also influence overall system balance. Installing non-recommended tire sizes or aftermarket wheels without proper specifications can interfere with sensor calibration, traction control, and range estimation. The vehicle continuously calculates performance metrics based on precise data inputs, and altering these variables without alignment can create inconsistencies in both handling and energy predictions. And cabin technology is built to respond intuitively, but repeated forceful interactions with the touchscreen or improper cleaning techniques can lead to premature wear. The interface is designed for light, responsive input, and maintaining its condition ensures uninterrupted access to critical vehicle functions. Similarly, placing excessive weight or pressure on seats, armrests, or storage compartments can gradually affect structural integrity. And another frequent oversight involves neglecting firmware-driven features designed to optimize long-term health. Battery preconditioning before fast charging, for instance, is not simply a convenience. It prepares the cells to accept energy efficiently while minimizing thermal stress. Skipping this process repeatedly introduces subtle strain that compounds over time. The same applies to scheduled charging, which balances grid demand and battery conditioning simultaneously. And environmental awareness plays a critical role in preserving performance. Driving through flooded areas or exposing the undercarriage to corrosive elements without proper cleaning can affect sensitive components. While the vehicle is engineered with durability in mind, consistent exposure without maintenance increases the likelihood of wear in areas not immediately visible. And storage inside the vehicle should also be approached with consideration. Leaving electronic devices, liquids, or heat-sensitive materials inside during extreme temperatures can impact both the items and the cabin environment. The vehicle's climate systems can mitigate these effects when used appropriately, but ignoring these features reduces their protective benefits. And energy management extends to how auxiliary systems are used. Running climate control at maximum levels, unnecessarily leaving lights or entertainment systems active when not needed, or overusing energy-intensive features without awareness gradually reduces available range. The system provides detailed feedback, and using that information allows for better control over consumption patterns. And connectivity features are another dimension that requires attention. Maintaining stable software connections ensures accurate navigation, real-time updates, and seamless integration with mobile applications. Ignoring connectivity issues or failing to address network inconsistencies can limit access to features that are essential for the full ownership experience. And vehicle cleaning practices also influence longevity. Automated car washes with harsh brushes may damage the finish or sensors, while improper drying techniques can leave residues that affect visibility systems. Using recommended cleaning methods preserves both appearance and functionality, especially for cameras and sensors that rely on clarity. And load management inside the vehicle impacts more than just comfort. Uneven distribution of cargo weight affects handling dynamics and suspension performance. The system is calibrated for balance, and maintaining that balance ensures that all components operate within their intended parameters. And regenerative braking settings, when misunderstood, can lead to inefficient driving patterns. Learning how to modulate acceleration and deceleration in harmony with regenerative systems not only improves range, but also creates a smoother driving experience. It's not just about letting the system work, it's about working with it. And even small software settings such as incorrect driver profiles or misconfigured preferences can subtly alter the driving experience. Ensuring that profiles are accurately set allows the system to adapt correctly to individual habits, optimizing comfort and efficiency simultaneously. And parking habits also contribute to long-term condition. Consistently parking in tight spaces or areas with high exposure to potential contact increases the risk of minor damages that accumulate over time. Utilizing built-in assistance features helps minimize these risks and preserves the exterior condition. And every interaction with the vehicle, from how it is driven to how it is maintained, contributes to its overall lifespan and performance consistency. The system is designed to deliver precision, but it responds best when that precision is matched by informed, deliberate use across every aspect of ownership, and long-term ownership also depends on understanding how calibration systems adapt over time. Sensors, cameras, and onboard algorithms continuously refine their accuracy based on driving conditions and environmental exposure. Ignoring the need for occasional recalibration, especially after tire changes, alignment adjustments, or windshield replacements, can lead to reduced precision in driver assistance features. Maintaining calibration ensures that every system continues to operate within its intended parameters. And door mechanisms and handles designed with streamlined integration require mindful use. Applying excessive force or ignoring resistance during operation can strain internal components. These systems are engineered for smooth, deliberate interaction, and consistent misuse introduces where that may not be immediately visible, but becomes significant over time. And lighting systems, both interior and exterior, are optimized for efficiency and visibility. However, failing to monitor their condition or ignoring alerts related to lighting performance can compromise safety. Keeping lenses clean and ensuring proper functionality allows the system to deliver consistent illumination, especially in low visibility conditions. And another overlooked aspect is the importance of maintaining proper software settings for navigation and route planning. The system calculates energy consumption based on terrain, traffic, and driving behavior. Overriding or ignoring these recommendations can lead to inefficient routes and unnecessary energy use. Trusting and understanding the navigation intelligence enhances both convenience and performance. And windshield and glass maintenance plays a larger role than expected. Sensors and cameras rely heavily on clear visibility, and even minor obstructions such as dirt residue or small cracks can interfere with their accuracy. Regular cleaning and prompt attention to damage preserve the integrity of these systems. And climate control efficiency is closely tied to user behavior. Frequently changing temperature settings or operating the system at extremes without necessity can increase energy consumption. Gradual adjustments and reliance on automated climate features allow the system to maintain comfort while optimizing efficiency. And charging port care is another detail that contributes to reliability. Exposure to moisture, dust, or improper handling can affect connection quality. Ensuring that the port remains clean and protected when not in use prevents potential charging interruptions and maintains consistent performance. And software-based security features are designed to protect both the vehicle and user data. Failing to enable or properly configure these features reduces their effectiveness. Utilizing available security settings ensures that access remains controlled and that the system operates within a Overusing framework. And driving in varying terrain requires adaptive awareness. Steep inclines, rough surfaces, and uneven roads place different demands on the vehicle's systems. Adjusting driving style to match these conditions reduces unnecessary strain on suspension and drivetrain components, preserving their longevity. And interior airflow management is often underestimated. Blocking vents or obstructing airflow paths with personal items disrupts the system's ability to regulate cabin temperature efficiently. Keeping airflow pathways clear allows the climate system to function as designed. And routine inspection of seals and weather stripping helps maintain cabin insulation and protects against environmental intrusion. Over time, exposure to elements can degrade these components, and early detection of wear prevents larger issues related to water ingress or noise. And energy monitoring tools provided within the system offer detailed insights into consumption patterns. Ignoring this data limits the ability to make informed adjustments. Regularly reviewing energy usage allows for more efficient driving habits and better understanding of how different factors influence range. And even the way doors and trunks are closed contributes to long-term durability. Allowing them to latch naturally rather than forcing closure preserves alignment and reduces stress on mechanical components. These small interactions, when repeated over time, have a measurable impact. And the integration between mobile applications and the vehicle extends control beyond the cabin. Not maintaining updated applications or ignoring connectivity permissions can disrupt this integration, limiting access to remote features that enhance convenience and monitoring. And external environmental exposure, such as prolonged contact with tree sap, bird droppings, or industrial pollutants, can affect the vehicle's finish if not addressed promptly. Regular cleaning and protective measures help maintain both appearance and surface integrity. And understanding the balance between performance and efficiency modes allows for a more controlled driving experience. Continuously operating in high-performance settings without necessity increases energy consumption and component wear. Selecting the appropriate mode based on driving conditions ensures optimal system balance. And attention to detail defines the ownership experience. Each system feature and interaction is interconnected, forming a cohesive environment that responds to user behavior. Consistency and mindful usage ensures that the vehicle continues to deliver the level of performance, efficiency, and reliability it was engineered to achieve. And battery awareness extends even further when considering long-term charging patterns across different environments. Charging in consistently unstable power conditions or frequently interrupting charging sessions mid-cycle can create irregular balancing within the battery pack. While the system is designed to manage these variations, maintaining a steady and predictable charging routine allows internal balancing processes to operate more effectively, preserving consistency across all cells. And attention to software-driven diagnostics is equally important. The vehicle continuously monitors its own systems and provides alerts that may seem minor at first glance. Ignoring these notifications, postponing checks, or dismissing warnings without investigation allows small inefficiencies to evolve into larger concerns. Acting promptly on system feedback ensures that performance remains aligned with design expectations. And surface protection plays a deeper role than aesthetics. The exterior finish is engineered to withstand environmental exposure, but repeated neglect, such as allowing contaminants to sit for extended periods, can gradually compromise protective layers. Applying appropriate protective coatings or maintaining regular cleaning routines supports both durability and visual integrity. And cabin noise levels can also serve as an early indicator of underlying issues. Subtle increases in vibration, wind noise, or mechanical sounds often reflect minor misalignments or wear. Paying attention to these changes and addressing them early prevents more extensive repairs and maintains the refined driving experience. And efficient use of regenerative braking requires not only understanding but consistency. Sudden transitions between aggressive acceleration and abrupt deceleration reduce the system's ability to recover energy effectively. A more balanced driving approach allows regenerative systems to operate at their highest efficiency, extending range while minimizing wear on traditional braking components. And managing digital storage within the vehicle is another subtle yet impactful factor. Features such as dashcam and Sentry recordings rely on storage devices that must be maintained, formatted, and monitored. Allowing storage to become full or corrupted can interrupt these functions, reducing their reliability when they are needed most. And the structural integrity of the vehicle also benefits from mindful everyday interactions. Leaning excessive weight on doors, using panels as support, or applying pressure to areas not designed for load can introduce minor deformations over time. These changes may be gradual but can affect alignment and overall fit. And maintaining optimal visibility is not limited to keeping glass clean. Wiper blades, washer fluid quality, and proper system calibration all contribute to clear sight lines. Neglecting these components reduces effectiveness during critical moments, particularly in adverse weather conditions. And the vehicle's suspension system is finely tuned for a balance between comfort and control. Repeated exposure to rough driving surfaces at high speeds without adjustment can accelerate wear. Adapting speed and driving style to road conditions preserves suspension components and ensures consistent handling performance. And interior electronics, including charging ports and connectivity interfaces, require careful handling. Forcing connections using incompatible accessories or exposing these components to debris can reduce functionality. Using certified accessories and maintaining clean some perk points supports reliable operation. And thermal management systems operate continuously to regulate both battery and cabin conditions. Blocking airflow to cooling vents or ignoring the need for proper ventilation during extreme temperatures can limit system efficiency. Allowing these systems to function without obstruction ensures stable performance across varying climates. And even parking orientation can influence long-term condition. Positioning the vehicle to minimize direct exposure to harsh environmental factors, such as prolonged sunlight or strong winds carrying debris, reduces cumulative wear. Small adjustments in parking habits contribute to preserving both exterior and interior materials. And user profiles and personalization settings are designed to create a tailored experience, but inconsistencies in their use can lead to inefficiencies. Regularly reviewing and updating these settings ensures that the system continues to adapt accurately to preferences, optimizing both comfort and performance. And the integration of navigation with energy prediction is one of the system's most advanced features. Overriding suggested charging stops or ignoring energy forecasts without proper understanding can lead to unnecessary jintha during suffering. Trusting the system's calculations and planning accordingly enhances both convenience and confidence. And maintaining awareness of firmware evolution is essential. Each update refines system behavior, sometimes altering how features respond or interact. Taking time to understand these changes ensures that the full benefits of improvements are realized rather than overlooked. And attention to minor tafasila defines the difference between standard use and optimized ownership. Every interaction, whether physical, digital, or environmental, feeds into a system designed for precision. Consistent alignment with that precision allows the vehicle to maintain its intended balance of innovation, efficiency, and al-adao.